twisted ring counter or Johnson's counter. You know already ring counter or shift register counter in the last class, correct? It is also same like your ring counter, only the ring we are given straight line in the ring counter, but in this twisted ring counter the ring input we are given to complement line. So that is only the difference. The difference between ring counter to twisted ring counter is the difference between ring counter to twisted ring counter is the feedback ring will be shifted to complement line. The feedback ring will be shifted to complement line. Just check it. You draw like ring counter. How we have drawn? You know, this is a synchronous counter, so that all clock pulses are same. Correct? This is CP, right? Clock pulse. So I am designing for 4-bit twisted ring counter. That is why 4 flip-flops we have taken. So all clocks should be same. That is why common clock I am supplying for all the flip-flops. Clear? Then, you know, in ring counter as well as twisted ring counter, we are going to use D flip-flops. Because we are going to use these flip-flops to transfer the data, we are not going to perform any operation. So that is why D flip-flops we are taking. D flip-flops is not a transfer flip-flop, transparent flip-flop or data flip-flop. So it will be transfer the data as it is. So first flip-flop output is connected second flip-flop. Second flip-flop output is connected to third flip-flop input, and a third with fourth. And in this ring counter flip-flop or shift register flip-flop, the Q4 straight line ring will be connected to first flip-flop. The difference is the twisted ring counter or Johnson counter flip-flop. The difference is the complement line output should be connected with the first flip-flop. Are you following? This is the only difference for your logic circuit. Clear? This is what MSB. This is the first flip-flop output is a LSB. You know already. Okay? Okay? Only the complement line output we are connected with the first. That is the only difference between your ring counter with twisted ring counter. Otherwise, remaining things are same. Clear? And also, you know, the positive, here positive clock edge we are giving for this. You can do it negative clock edges also. Yes or no? I'm using positive, you do it for negative also. So how the truth table will be constructed. So first one is the clock. Then what happening? Q4, Q1, Q3, Q2, and Q1. These are the states we are going to consider. Then we need to check how this is going to work. Correct? So in basic, initially the clock is 0. For this, whenever the clock is 0, what is happening? The states are 0, 0, 0, 1. You know this. These are the same thing we are following for your ring counter. So means what is happening here? Whenever I am giving this, what is happening here? 0, 0. I think no. You have done. Just check it. 0 is for what? Q4 is 0, Q3 is 0, Q2 0, Q1 1. Correct? Yeah, this is initially. Correct? So then I am supplying a clock now. Before supplying the clock, this output will be connected to first flip-flop. Yes or no? What is the output here? Q4 is 0. When Q4 is 0, what is the complement of Q4? What is the complement of Q4? 1. So 1, this 1 will comes to here, it should be ready. Yes or no? Yes or no? Now what I am giving? Supply is given, means your clock will be 1, edge clock. Then first flip-flop is going to trigger. When first flip-flop is going to trigger, what is going to happen? This will comes to here. Only D flip-flops are going to transfer the data, push the data. Yes or no? There is no any operation. Then this will 1 comes to here, this 1 comes to here, this 0 comes to here, this 0 comes to here. When it is 0, then what is the Q4 dash? It is, when it is 0, what is this? This is 1. Yes or no? Then present situation, what is the outcome? Now tell me what is Q4? Q4 is 0, Q3 is 1, and Q2 is what is Q2? No, this is 0. Q3 is 0. Now Q2 is 1. Q1 is 1. Correct? Correct. Right. Now again I need to give one more clock. Clear? Before giving the clock, this one comes to here ready for the input, waiting for inputting for the next clock. When I am giving the clock, that is 2, then what is happening? This one comes to here, this one comes to here, this one comes to here, this one, this is 0, this is 0. Huh? Q4 0. This 0 comes to here, 0. Right. When it is 0, this is a complement. Correct? Now tell what is going to happen here. 0, 1, 0, sorry. 0, 1, 1, 1. Correct? Your output is correct? Yes? Then before giving a clock, this will 1 comes to here ready to give the input to first flip-flop. Okay? Now I have given a pulse, positive edge pulse. So positive edge means always it will take 1. Yes or no? So when it is there, then I am giving clock is 3. When I am giving clock 3, clock 3. What is happening? This input 1 will come here. This will be activated, trigger. So this one will come here. This one comes to here. Now this one comes to here. Now Q4 complement is 0. Right? Now tell me what is the third cycle? 1, 1, 1, 1. Okay. Then before giving next clock, what is happening? This is over. Before giving next clock, this 0 will comes to here. Now it should be ready. Then I am giving the clock. When I am giving the clock 4, then what happening? 0 moves to here. This one moves to here. This one moves to here. This one moves to here. Yes or no? Now one complement. What is one complement? 0. Right? Then what is 4 here? Tell me what is the Q4? 1, 1, 1, 0, I think. Correct? Right. Next, before giving the next clock, what happened? This 0 comes to here. Now waiting for the triggering, waiting for the clock. So then I am giving next clock. Okay, when I am giving next clock, means that is 5. When I am giving next clock, what happened? This 0 moves to here, this 0 moves to here, this one moves to here, and this one moves to here. So if it is 1, it should be 0. Then what is happening? 1, 1, 0, 0. Right? Now before giving clock, this 0 ready for the inputting. When we are giving clock, then it will be ready to trigger. Okay, I am given the clock, then that is 6. Then this 0 moves here, this 0 moves here, this 0 moves here, this one moves here. It is 1, it is 0. This is 0. Then what happened here? 1, 0, 0, 0. Correct? Next, before giving clock, this 0 will come here. Ready for this. Next I am giving clock. Then what is happening? This 0 moves to here, 0 moves to here, 0 moves to here, that 0 moves to here. Now it is a 1. So tell me 0, 0, 0, 0. Okay. Next, when I am not giving clock, ready, this will be ready. 1 will comes to here waiting for the triggering of the first flip flop. So input is ready. Then when I am triggering, then what is happening? This 1 will be transferred to here, 0 moves to here, this 0 moves to here, this 0 moves to here, and 0 complement is 1. Now what is the status now? 0, 0, 0, 1. So now it is equivalent to huh? No, 0 will come. 0 will come. So now it is like it is equal to initial state. So it is going to stop the counter. Are you clear? Are you clear? If this is a twisted ring counter or Johnson counter. When you observe this, it is almost similar. Only the thing is, we are giving the ring for the complement line. That is why it is taking 8 clocks. So direct ring counter, we have only 4 clocks or 4 bits. But here 8 clocks. Are you clear? So this is the difference between ring counter and twisted ring counter. Okay.